kérem fogadják szeretettel szintén a Wrocławi Egyetemről Agnieszka Letowskát. Kérem, tartsa meg előadását.
Today I want to present for you my research work on one project with old press from Polish lands in the end of 19th century and beginning of 20th century. My topic is processing digitized historical magazines, challenges and solutions. And I called it also From Dust to Data because these historical magazines are quite often not in good shape. Okay. As I said, I will share with you my experience working with digitized historical journals, especially Polish and Yiddish, but not also. I work with 5 languages on this project. It's Polish, Yiddish, Hebrew, German, and Russian languages. And the methods I use to extract meaningful data from them. This is a journey from crumbling paper to searchable, analyzable texts, which is not easy in many cases. Why historical journals matter, I think you know better than I, as historians. For me, it's a very rich source of knowledge about everyday life, health, culture, science, politics, everything you want to find out about times we are talking about, we can find in newspapers. They were really writing everything in these magazines and newspapers. It was our social media, television, internet, and newspapers. It also often shows often overlooked in mainstream archives, so we can find there much more information than in normal, typical archives. And it is a vital resource for understanding minority voices and underdocumented communities, like Jews, on which is my project. I will tell you about this project shortly, because I work as a voluntary in a Jewish faculty at University of Wrocław, and I participated to the team as a technical worker. I don't research and I don't find information in that sources. I'm just for finding keywords in these new papers, and this is the job which really make faster research for other scientists. Here I have few examples of my researching newspapers. It's Ruski Yevrej. It's, of course, Russian newspaper. Ewa, it's typical Polish, Jewish newspaper. It's very feministic. So there is a lot of topics from my scope. And there is Jiddische Frauenwelt in Yiddish, which I don't understand not at all. The challenge begins. The problem with digitized sources, there is a lot of problems with digitized sources, but if they are digitized, it's really good because many of them aren't. And we can't use computers to search anything in not digitized sources. Many journals have been scanned by major libraries. For example, Polish National Library, Polona, National Library of Israel, university libraries from many countries. And the source are really depend, the quality of texts is really different. And I really don't know what I will find in these sources, what kind of text I will find, and how good is the quality of them. But scans are often image only, so they don't have searchable text layer. They just are pictures and not text. OCR, it means optical character recognition, what Piotr was mentioned. It's a method which allows to read texts from pictures. So it often fails because of many problems, especially in languages like Yiddish, but also in old version of other languages, and due to old fonts, poor scans quality, print damage. I will show you in next picture. Keyword searches are unreliable or impossible sometimes. And I have in my project common problems. Due to the fact that I work with old materials, often over 100 years old, I struggle with many problems. There are problematics library-dependent newspaper and magazine downloads option. For every library, I have to create new program, computer program, to download it automatically. If not, I have to download it manually, which is very time-consuming process. But if I have good program, I sometimes create. Sometimes it's not possible. I can download few thousand magazines in one day. So it's really fast job. Okay, the second problem is damaged source materials. Many of them are really old and doesn't look good at all. Background noise and low contrast, incomplete OCR, optical character recognition, or gibberish output, missing or broken metadata, no consistent format across collections, and lack of support for non-Latin scripts. It is shown on Yiddish especially. Okay, and here I have some specific examples to show you what is the problem. Here we have Eva. This second, does it work? Yes, this is Eva. And as we can see, it's terribly damaged. We can't read text if there is no text in the newspaper. So it's unreadable, unfortunately. Here we have Ruski Еврей. It's a wonderful font, and it's really a good shape, but we can see that the font is not for today. This is za niedzielu. Yeah, here is this letter, and yeah, here is quite different letter. And it's not in actual alphabet. And of course, Old German, Allgemeine Zeitung des Judentums, is also written in really old font, which is really pretty, but not to the end readable. And the worst. First, Volksgesund in Yiddish. As we can see, there is Yiddish, but here are separated letters. There are not words. That's why our computers will not read it. There are single letters, which is unreadable at all. And here, I wanted to show you one of problems with Yiddish. Here we have, at first, Yiddish part of newspaper. It looks good. If we could read Yiddish, probably we would read this. But computers read it like that. And here we have totally unknown shapes. Some are some different signs. And I've tried to show you how computer read it and how translate it. So here is in Hungarian translation of this piece of paper. And look at this. Does it make sense? For me, too. And here is in English, if someone would prefer. It doesn't make sense. I translated it in Polish, and some words are readable, but almost nothing. It's logical. Okay, so I have to somehow deal with these problems. And my approach, step by step. Identifying and downloading PDFs from library websites. And as I said, it is really time-consuming to process, but if there is possibility, it can be really fast, few thousands of issues in 1-2 days. It depends on library. Some libraries are really good in cooperation with scientists, some aren't at all. I can't even find a title of one magazine because it shows me hundreds different things, not this title, even if I write it properly like it is written. If the text layer, after I download it, if the text layer is readable, I go to the last step, which will be on the bottom. But if not, what is really common, I have to convert PDF pages to images, page by page, pre-processing the images to improve OCR, running OCR on each page, using Tesseract language models, and cleaning the output and searching for keywords, and after that, highlighting and exporting results. This is how do I pre-process this text. At first, I make the image easier to read, but by the computer using few steps. At first, convert to grayscale. Some of these newspapers, as you can see, are brown, beige, any other colors because of the age. But I need them to be gray because then I turn it into black and white to make bigger, better contrast. And after turning into black and white, I remove background noise. That's why the letters are better seen. Smooth the image to avoid distortions, and in result, I've got slightly cleaner image, which is much better to OCR accuracy. It means it's better to read for computers. Okay, and now OCR. I use open source OCR engine, Tesseract, which is open source and for free. That's why I use it, not only because it's also a very good tool. It has, I think, almost every language in the world. Then I can use custom language files because I need to update to every language, every program. And if Tesseract doesn't work good enough, if the text is still not perfect, but allows us to read and analyze pages without typed text, I can read it and search for my keywords. But if not, if the computer almost recognizes words but not fully, I use fuzzy matching. It's a process in which I don't recognize words as words, but as pictures. Typical words have shape, and after this shape, I recognize keywords in texts. Fuzzy matching compares what was recognized to what we expect to find and looks for similar words, not just exact one. It can be a little bit different, and we can choose how much we allowed to be different than original word. And it's useful for dealing with topos, broken forms, and partial matches. Here is part of my program. Okay, here are my keywords for Yiddish. My team created over 100 keywords. It's not easy to search newspapers, especially when you're sitting and reading it, and you have to find 100 keywords in thousands of issues of papers. So, in my project, the keywords are related to health, clothing, gender, etc., because it's discourses on body. This expanded list is expanded to include different word forms and spellings. And my program search each OCR result for matches using fuzzy matching. It means it searches for special shapes. And here there is one newspaper, one page. I was working with it 3 times, and at first time 70% of similarity between word and the shape is shown, and the yellow words are in theory these words which I'm searching for. And in the second picture, there is 80% of similarity, and in this third, it's 90%. And as we can see, it's not perfect tool. Here we have something which for sure is not any word in Yiddish. And here with similarity 80% still shows not words. But here we have quite clean text with probably just words which we are searching for. But after consultation with my team, they decided to use this, because some words here are not showed. Here there is better method for them, because it shows much more words. This exactly paper is about tuberculosis. That's why it's so yellow. All this newspaper is yellow because it's about health. And it shows good results. And why it matters? This method helps make hidden text searchable. So if we can't find in typical text, words which we want to find, it helps us find this. It saves researchers weeks or months of manual reading. I will explain it in a minute. And it makes rare materials more accessible and usable. And I think it's understandable. About this saves researchers weeks or months of manual reading. I was asked to search one word in one magazine from year 1883 to 1910. It's 27 years, about 50 magazines at every year, and about 10 pages in every magazine. It gives over 30,000 pages. And how do you think, how long would it take to read it and find this one word? Months, years, maybe? Okay. My program worked about 1 day. And I found it in 5 journals, which my program showed me, and underlined like this before at yellow. And it's just in 5 numbers of this magazine. So it took just 1 day. So applications of that method. It's of course historical research. And we can find anything what you want if you want to search some documents, old documents, but of course digitalized. Library indexing and metadata enhancement, and digital exhibits and public engagement. So I think we could find another applications of that method, especially in history research. Future potential, it's multilingual expansion. Of course, we can expand it in another new languages. Training better OCR models for historical fonts. And yes, it would be great if libraries, digitalized libraries could use it to train their OCR models. Creating searchable annotated archives and connecting journals across collections. It can be used in really many new applications. Okay, my final thoughts. This work sits between technology and history, and it shows that even poor quality sources can be made valuable again. By combining simple tools, open data, and thoughtful research questions, we can rediscover hidden voices from the past. And thank you very much.